collaborate with ASBME today. I'm running the Arduino tutorial. I guess if you want to wonder like why I'm doing it, I'm a CP for EE 109, which is the class that kind of works with Arduino. And so I will be teaching you some of the basics of how to work with Arduinos so that you guys can use it in your personal projects or the Make-a-thon or whatever you can get your hands on really. So let's get started. So I'm going to talk briefly about the anatomy of an Arduino. So you can see it here, that's an Arduino. If you want to look at this kind of big port, this is the port to receive power and data from the computer. So the important part to realize about this, that this is a programmable device. It's not a standalone thing like your PC is. So basically you need to write some code on your computer and then port it into the Arduino with, I think it's a C to A cable, whatever it's called, so that the Arduino can actually receive data from it. As you can see here, these are some digital pins. These can be used for digital input or digital output. Digital just basically means that the signal is either going to be a 0 or a 1. There's no continuous value, it's just very discrete. The next thing to notice here are the 6 analog pins. Analog means that it's not discrete, so the values are continuous. These are also the last set of pins that you need to know are the miscellaneous pins. These are power, these are ground, and some other ones that we really don't use, so we don't have to focus on here. I guess one thing that I want to stop and talk about really briefly is that I think this tutorial will be useful even if you have taken EE 109, just because in 109 we programmed this chip over here, the AT Mega, directly using like a toolkit called AVR. But usually the Arduino IDE makes it really easy for you to program the Arduino. So hopefully, even if you've taken 109, you'll learn something from my tutorial today. Let's move on. So just to kind of visualize this a little bit, this is the information flow. As you can see, there's a computer here, so you can write code here. It's going to be compiled here, translated into machine code, then sent into the Arduino using this port over here. And then as you can see, you can put a lot of input and output into the Arduino. Like for instance, this input here is going to be the sensor that can tell how close your hand is away from it. That's going to be your input. Input signal is sent directly into this digital pin over here. This output can be an LED. So as soon as the Arduino processes what's happening with the input, it can actuate an output using the output pin. So let's kind of go over that a little more in detail here. I guess before we do that, I should kind of clarify what exactly Arduinos are used for. And I guess the easiest way I can say this is proof of concept projects. You guys are bioengineers, chances are you guys will work with electrical components in your career, but these are not production level. Like, if you're making a cardio, okay, I'm not even gonna try something using electrical products, you will not be putting an Arduino in the body, right? These are for prototyping, these are for hackathons, personal projects, class projects. But the thing to take away here is that this is for testing and kind of playing with, but definitely not production level. So you probably won't work with these in your workplace. But what can you do with them? If you have any sort of project that needs sensory input and actuating output, an Arduino is a great thing to work with. I'm sure you guys have worked with some basic C, maybe C++, Python, Java. As you probably remember, you're really limited to the input on your computer, which is basically the terminal or the command line, whatever you call it. And that can be really limiting if you're doing make-a-thon projects. So for this, you can use inputs like humidity sensors, sound level sensors, time. You can connect it to Wi-Fi. You can use a Bluetooth module. You can do a lot of different things with this. And some examples of output can be motors, servos, LEDs, the list goes on. So I'm going to kind of show you some examples of Arduino projects that I have worked with either in makers or just for fun outside. So this one is going to be this shooting game that someone in makers made for a build day that I organized. As you can see, this logic is all controlled by the Arduino. You can't really see my finger there, but I'm pressing on these buttons to move this little blue spaceship around. And it's basically a replica of Space Shooter. So here the inputs are the button presses, so you can move the ship around. The output is the LED on an LED matrix. And then the job of the Arduino is to generate the bullets, parse the input, and then move your ship around and shoot. Let's move on to a second example. If this will work. Perfect. This is another example with the LED panel. Let me see if the sound will play on it. I don't know if the sound's playing. Does the sound play? Oh, perfect. Awesome. So the input here was basically the sound level. And then with the microphone, we were able to record the sound level of the music that was playing. And then the output was the LED on the LED's matrix. So the job of the Arduino here was to parse the sound input and generate an output depending on the sound. The last example I have really quickly is I try to do it more like biomedical centered, but this was a glove that me and my team made that makes rehabilitation exercises fun for elderly patients. And so as you can see here in this video, as you move your hand, it kind of corresponds to an LED, so it lights up. So it's supposed to gamify their rehabilitation therapy exercises. And we also had another web app, but that's not really related to the Arduino. The input was resistance measurements from the flex sensors. Output was the LED output, and the Arduino's job was to check if the flex sensors were bent or not and light up the correct corresponding LEDs. So this is, now that you have like kind of like the most basic introduction, let's go over what you guys are going to be doing today. You guys will be building a circuit that will be able to enable light therapy. So the LED will basically blink at a frequency of 40 hertz. If I'm not wrong, that's every 0.025 seconds. Actually could be wrong on that. And the inspiration I got was actually from Advaita, because I know you guys take this class called BME 202. I think. And then the final project, you're supposed to kind of, I'm not sure what the final project is, but what she did was she worked with an Arduino so that she can enable light therapy for rats who are experiencing Alzheimer's. If any of that is wrong, you can correct me in the chat actually, but that's what I got out of it. And that's what you guys will be doing today. So basically the objective here is that if you click on this button over here, it's gonna enable the LED to flash and just keep flashing at that certain frequency. So before you guys work with the components, you guys probably want to know what the components do. So this is the LED. Oops. This is the LED. And basically, it does what you think it does. It lights up, right? But the parts that you have to know is that the long end is called the anode. The short end is called the cathode. And you have to connect power to one end and ground to the other end. So as electricity flows to the LED, you want the LED to light up, right? Which is why you need power on one side, ground on one side. It's one directional though, so you can't mess up where you connect the power and ground, but I'll guide you through that. That's totally okay. The second thing I want to highlight here is that you always want to connect the LEDs in series with the resistor. I'm sure you guys all took physics. Resistors just make sure that you don't burn out the LED. So again, we're going to look at this circuit. You have ground here connected to the cathode, and then the anode connected to power, but there's a resistor here, so we don't burn out the LED. Super easy. Now we're going to meet the button. As the name implies, you can detect presses when the button is pressed and when it's not pressed, which makes it a really nice input to work with. You need to connect one side to ground with the resistor, and then you need to connect the other end to power. Then you can add an input line to measure the current flow in the button. So basically, if you press the button, you're completing the circuit. If you don't press the button, the circuit is floating. So therefore, if you're trying to measure the voltage difference across the button when you press it, that's going to be a digital 0 because you're completing the circuit. All of the power from the voltage source is going straight to ground. So there's going to be no voltage difference. But if it's open, so you're not pressing it, the voltage difference is just going to be VDD minus ground. So that's usually 5 volts. You don't have to worry about it too much because the Arduino abstracts it for you a little bit, but just wanted you guys to have some of the intro. If I'm going too fast or if you have any questions, please drop them in the chat also, just in case. Okay, well, I think we can try coding now. So we're gonna use this web platform called Tinkercad. Basically, I've registered all of you guys as students in the class. Let me drop the link. Or Advaita can drop the link. It's a contest between us. Oh, she got it first. And then basically your nickname is going to be your first name and your last name squished together, no uppercase, all lowercase. So the example here is if your name is Jenny Lee, then your username is Jenny Lee, all lowercase. And you have to register with your nickname. And let me know if you have any trouble because I might have forgotten to register someone. I might have registered with the wrong name, things like that. So we'll give it maybe like, yeah, we'll give it a few minutes and then we'll see. Oh, I see. There's more people to register. Give me a second. Let me try to register the 2 people first really quickly and then I'll look at it. Okay. Oh, okay, so I think these people are in already. Who did you say wasn't working? Shakti. She put her name in the chat. Oh. Oh, Joelle, you should already be registered. I think I remember registering you. Joelle's up there. Let me know if you see it. Here. There. Is this one? Did I misspell something? Oh. So that's to refresh the page. Okay. Let's see. Could there be an issue if we have a pre-existing account associated with you? If you already have an account, you don't necessarily have to join this classroom. You can just log in through your account. That should be fine, Lydia. And then Brianna, okay. Brianna's store. Oh, it worked, awesome. Okay, is everyone in? 1, 2, 3, 6. Okay. If everyone is in, if everyone's not, if anyone is not in, please put it in the chat. It says there needs to be a code. Huh, maybe there's a code. Maybe this code? Okay, cool. Let's get started. So I'm assuming that this is kind of what your guys' dashboard looks like. I think on default, you're on 3D designs, but you're going to want to click on the circuits page because you're going to build a circuit. As you can see, I've done this tutorial this morning. So let's create a new circuit. Oh, yes, our Wi-Fi made it. So basically, this is just a blank workspace where you can simulate working with an Arduino. You can kind of work with some hardware on this side. I hope you guys can see this works. Okay. This is where you can organize your hardware, and then you can click on this code bar to add some code to your pre-existing hardware. So let's just start. first we need an Arduino, right? So on this sidebar, search for Arduino, and then you click on it, and then you should be able to drag it here, and then you can place it down. You can name it if you want. I'll name mine Arduino. Okay, and then you want to be able to put down a breadboard. I'll explain what a breadboard is in just a second, but I would just get a small breadboard, drag it over, put it down. And this breadboard basically makes it so that you can make electronic connections without having to like solder together wires. So basically, if you put one thing here and then you put another thing here, they're going to be connected. So if you see where my mouse is and it highlights green, right? So all these things are going to be connected. If you place something in here, it's going to be connected to this, 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 and this. Does that kind of make sense? If you put something here, you're going to be able to make a connection to any of these. Why you have these kind of horizontal lines at the top is that this is for power and ground. So we need a source of power and we need a ground that's going to suck away all that power to create that voltage difference, right? So basically, we only have one ground or one power pin, and we don't want to, you know what I mean? We don't want to keep making connections to that. So if you connect power to this, it's going to power this entire row. Hopefully that makes sense. If anyone has any questions, feel free to stop me anytime or put it in the chat and I would be happy to answer. But let's get started. So we're gonna just try lighting up an LED without anything else, just to see how it works. So let's look for an LED. And then we're just gonna drag that over. And then let's just put it here. And then I think you guys probably remember about the cathode and the anode, how you want to be able to put that in the right places. So first let's give power to this place. So connect the 5V pin to here. And usually conventionally when we're making a circuit, power is always red. So I'm just going to do it. It makes it easier on the eyes. And then let's connect ground to here. And then conventionally ground is always black. Ta-da. So now basically we provided power to every single pin here. So if we want power, we could just connect it to any pin here and it's going to give power. Same for ground. Now we remember that we want to connect the cathode to ground. But what we wanted to do is also put a resistor there so we don't burn out our LED. So let's Google for a resistor. There's one over here. And then we're going to connect it in series with ground like this. And if you do that, you can see ground is connected to this. This is connected to the resistor. Resistor is connected to the cathode. We're not done with our circuit because we still need a power source. So then let's just take a wire here and take anywhere from the power line and then connect it to our anode. So now, if all goes well, hopefully I did this right. If we press start simulation, the LED should light up. So let's see if that works. Yay! I don't know if you guys saw it, but it is lit up. So as you can see, that's how you light up an LED. But you know what I mean? We didn't need an Arduino to do this. We needed literally just a power and ground. So now we're going to make it controllable with the Arduino logic as well as a button. Let's wire up the button really quickly. Okay, let's instead of unconditionally powering it with this power line, let's take out this one. And let's conditionally power it with the digital input. So let's just take pin D7 like this and then connect it over here. And what this is going to do is when you want it to, you can give power through this pin to light it up. And when you don't want it to, you can not give power. So it's going to light. So it's going to turn off the entire time. So if we press start simulation, the LED should not light up because we didn't provide any logic for the Arduino to give it power. Let's think about how we want to program this so that it can give power though. So if you click on the code bar over here, it opens up this part. This is in Scratch. Let's not work with Scratch. Let's use Arduino C. So go to the text part, say continue, and they have all this set up for you. I would just delete it. So there's two parts. There's a setup logic part and there's a loop logic part. The setup part is run once. So if you want to initialize variables, if you want to declare something as an input or an output, you do it in setup. However, if you want to do something over and over again, it's just basically an infinite while loop. Then you put it in the loop portion. So first we have to initialize pin 7 as an output because we are outputting power into this LED. So to do that, you have to set the pin mode. There's a function called pin mode, like this. And then you want to specify which number it is, which is 7, because we're connected to pin 7. And then comma, we want to specify as an output. And then semicolon, because it's C. All right, and all this does is it tells you that this Arduino on pin 7, it's going to be an output. And in the loop, let's make it blink. So what you can do over here is you want to power it. So you want to do digital write. Then we want to delay. Perfect. So what this does over here is that in this infinite while loop, you're powering it, delaying. So you're powering it for 250 milliseconds, a quarter of a second, whatever it is. And then you're going to turn it off for a quarter of a second. So it's going to flash on and off, on and off, on and off forever. So assuming I did everything right, that's the behavior we expect to see. Let's see if it works. So as you can see, it's flashing. If you want to change the frequency, you can just change the amount of time it delays, right? So let's say you want it to go slower, then you can make this 1,000. Start simulation. It's on for a second, off for a second, on for a second, off for a second. So really easily, we can get this LED to blink and flash. So that's good. Close the code. But now we want to introduce another input, which is the button. So now let's look for a button on this little sidebar over here. It's a little push button. Let's put it here, like this. And how the inputs are configured is that this one, terminal 1A and terminal 1B are connected, terminal 2B, terminal 2A are connected. Right, so now we want to give it power, we want to give it ground, right? We want to give it a resistor, basically the same 3 elements for any electronic little sensor, I would say. So first, let's give it power. It doesn't really matter which part you give power and which part you give ground, because in this case, it's not one directional like the LED was. You can put it anywhere. So let's give this part power. And then let's put it red because it's power. And then let's give this part ground. And then we want to use a resistor. Perfect, there's the resistor. And as you can see here, the circuit is completed because you have ground, 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 ground to resistor. The button is here, back to power. So we have a complete circuit. But we want the Arduino to be able to read what's on the button, right? So let's give it another input. Let's use pin D6. And then let's connect it right to the button here. Let's make this a different color. Let's make it purple. Like this. And now if you declare this as an input into the Arduino code, it's going to be able to read whatever signal is on the button. So as I mentioned before, if you press the button, that's a digital 0. So the Arduino, if it sees a digital 0, it's going to understand that the button is pressed. But this is kind of backwards because even though it's a digital 0, right, intuitively, if you press something, you think it's going to be a 1. So the Arduino IDE kind of like abstracted this a little bit. And if you check if the button value is high, that means it's pressed. That's a little bit confusing, but if I show you the code, it'll be easy again, I promise. So let's go back into the setup, and then we're gonna copy, we're gonna paste here, and then we're gonna set pin 6 as an input. Why is this an input? We don't want to drive output from here, right? All we want to do is read the value inside the button.
There's a question in the chat.
Oh.
Can we use the internal pull-up?
Can we use the internal pull-up? Yeah, you can definitely use the internal pull-up. If you want to use the internal pull-up, feel free to do so. Okay, cool. And now we're just gonna write the logic to check the button to see if it's pressed or not. And then if it's pressed once, then it's gonna start looping. So this is probably gonna be pretty intuitive for most of you guys. Let's create just a random flag. You have to declare it globally. If you declare it in setup, it's not gonna recognize it in loop. So I would just suggest that you declare it globally over here. And then let's do all right, so we just wrote some very, very basic code with this flag variable called start. So basically what it's going to do here is the Arduino is going to read pin 6 if the digital read for 6 is high, which means that the button is pressed, which is a little backwards from what I've explained to you, but that's because they wanted to make things easier for us. Then we're going to set start to 1. If start is 1, then it's just going to loop forever in here and say that the LED is going to blink forever. So let's set this back to 200 maybe, and let's see if it works. As we expected, the LED does not turn on. It should not turn on until I press the button. So with my mouse, I'm going to try pressing the button here, and it blinks. Yay! All right, that was the basics of my tutorial. I'll pause for questions here in case someone had any questions or someone's having trouble with the web application a little. I can show you guys how to use a buzzer. That's another pretty useful one for hackathons, or we can end things early. I'm sure you guys have 103 things to do. So I'll pause for questions here and I'll wait for questions if there are any.
We can keep going.
You can keep going for.
Yeah, we can do the buzzer.
Oh, want to do the buzzer? Yeah, okay, then let's start with the buzzer. Why not? All right, let's remove some of the components because it's getting a little messy. So let's just, if you hold it and you press the delete button, it all deletes. I love Tinkercad. Okay, so now that we've removed that, we probably want to put a buzzer in. I don't know why they call it a piezo. I don't know what that is, but let's put that in the breadboard. And like we did before, we're gonna need a power, we're gonna need a ground, we're gonna need a resistor. There was someone in the chat that asked if you could use an internal resistor. You can for most things. There are certain sensors that cannot use the internal pull-up resistor. You have to use a very specific resistor, but that you can read the documentation of. But for any of these, I believe you can just use the internal pull-up resistor. Connect to ground. We did this already, so I'm going to speed through it a little bit. All right, and then let's connect the power here. So we have the power, oh God. All right, let's get a resistor to connect it to the ground. Nice. And now we're gonna need an input line, right? Or sorry, an output line. So let's. Okay, so that's basically just the wiring of the resistor. Now let's start the code. We can delete a lot of things here, basically everything here. So pin mode 7 is still going to be an output, right? Because we want to, basically how this resistor works is that if it gets a signal to vibrate, like if it gets a signal to turn on, it's going to like release the frequency and then it's going to stop working and then it's going to release the frequency again. And that's how it makes the buzz sound. And you can change the frequency of the sound that it emits. You can make it buzz faster for a higher pitch, things like that. So now that you have that set up as an output, pin 7 is an output. Now we're gonna loop inside here, and then we're gonna use the command tone. And then let's do output pin 7, 6,000. And then let's make it delay for 1,000. Let's make it no tone. Then let's make it delay another 1,000. And what it does is it tells it to generate a tone for 1 second, turn off the tone for 1 second, generate a tone for 1 second, turn off the tone for 1 second, and it will go over and over again. These functions I should probably mention, like tone, pin mode, are internal to the Arduino. Maybe I'll open up the Arduino IDE, because when you guys are working on your projects, you probably aren't going to be using Tinkercad, you're going to be using the Arduino IDE. And there's basically all these libraries that you can import. You can check out the Arduino documentation as well as specific other third-party sources that use this, and then you can import those as a library. And then those libraries have inbuilt functions. So for instance, I'm not exactly sure what this one's for, but if you want to work with the Adafruit GFX library, you can look at documentation, and then you can, do the corresponding things that work with it. So my point there was, if you're confused about how I knew there was a function called tone or no tone or pin mode, it's all going to be dependent on the libraries that you choose to use and interface with your Arduino. Hopefully that makes sense. I don't think any of these are in like a crazy library. I think this is just like the default, but you can always Google it to see what it does. So you're not expected to memorize any of this when you're actually trying to make a product. All right, so this code should work. It's gonna make a really ugly sound, but I'll show it to you guys. Let's see. For loop, too many arguments, void no tone. I think I used that function wrong. Yep. Yeah, so that's the sound it made. You can kind of change the sound it makes by switching up the delays. This should change the frequency of the sound. Let's see if you can change this number over here. I don't remember exactly what it does. Let's see what it does. So with that, you can kind of also use a buzzer as an output, right? At previous hackathons, I think I've seen a team trying to use this buzzer to play music and things like that. That's one thing you can do with it. There's a lot of different sensors and things that you can interface with Arduino. Because we're on a web application, there's not that much variety. I can show you, this is about it. But I hope that everyone is able to kind of learn the basics so they feel confident on how they can kind of start their own project, as well as start to read documentation, start to wire sensors, and build really cool things in the future. I think that's all I have for today. I ended a little bit early, but I'll hang around for the next 10 minutes or so to answer any questions or anything like that. If you ever want to reach out and, I don't know, get a project started by yourself or something, I love talking to people about that. Feel free to ask advice about my email, reach out to me. Yeah, that's about it. Thank you to everyone who came.
Awesome. Thank you
So much, Shetty, for presenting. That was really great. It was very clear. Someone messaged me during the thing and was like, that was so clear. So yeah, it was a very clear, concise PowerPoint and presentation. If you guys have more questions about Arduino, I will actually drop Jenny's chat in our email in the chat right now. So you guys can reach out to her. Again, like I mentioned before, these are Arduino is used really often in the Makeathon. Even though we're virtual this year, Arduino will still be like a resource open to you guys if you guys want to use it and implement it in your design solution for the Makeathon. So A, if you're not registered for the Makeathon, you totally should be registered. But B, this is a super useful skill, and we'll be sending out this tutorial as preparation for the Makeathon. So it's super great that all of you guys were here. I'm going to go ahead and actually stop the recording. But